Hello, everyone. So, my name is Ricardo. Today's topic is about Airbnb production. Before we're doing the machine learning, we need to do the data preparation first. We need to load every package we need and install every uh, functions maybe we need to use in the machine learning. Then we need to reload the training data, and this is the data. So, and this is the train information of all of the data. This is the test data. We need to import the model in the test data after we train by the training data frame. It's the test info. As we can see, like shape is different. For the train data set, it has maybe 27,000 of rows and 16 columns. For the test shape, we have 6,800 of rows and 15 columns. After we did that, we can make a heat map to show the correlation between each vectors. And we cannot see some obvious relationship between the each vectors, but as we can see, the longitude have a negative relationship with price, and the minimum nice has have the correlation with the reviews per month. So as we can see, the latitude and longitude have some relationship between the price, but the correlation is not high enough. And we have to change all the coordinates to things like longitude and latitude. This is because longitude and latitudes are large number inside the data set. So we have to make like is a kind of way to standardize the longitude and latitude, make them more smooth in the data set. So and then we need to generate some new features such as the scores for in the data set. This is the way we did that is to make the data set has much more correlation between the price because we cannot find some strong correlation net here, holding the reviews and the number of reviews. So we have to make the reviews and longitude to a score and use the score to find some correlation between the price and these all factors. And this is non-value for the data training set. Thus, review and review per month has a lot of mm, non-value, so maybe we don't need them in the final machine learning. No duplicates, and this is the DF train describe is special, and this is the DF test describe. We said our y is equal to price, which we need to find in the DF test to make sure we correct the most accurate learning model. And this is our train data. We use the ID, and we have to drop that ID name, host ID, host name, last review, and neighborhood. And uh, I will talk about why we need to remove the neighborhood inside the data train after that. So there are some categorical features like neighborhood group and room type, the new numerical features, the latitude, longitude, minimum nights, number of reviews per month, calculated host learning count, and availability in 365. The reason why we define the categorical and numerical features is we have to do encode for the categorical feature and doing scaling for the numerical features. The reason why I need to remove the neighborhood is neighborhood have about like 5,000 or like there are multiple results in encoding. So it will makes the model uh too complicated and really hard to understand. and as well make the model more tend to overfitting. So I remove the neighborhood and I find the top 10 most important features inside the model, which is at here. This is the top 10 features important. As we can see, the room type is still not important inside the 10 feature importance, but we already use the room type inside the pipeline. So that's all. And we use the categorical transformer, the pipeline. This is encoding and numerical transformer and combine all the processor. And I tried the random forest regressor. The reason why I tried the random forest regressor is to find the first thing is to find the correlation, and the second way is to I have to lead the data set into 80 and 20 to make sure I can see the fitting to see the model is overfitting or not. And then I use the LGB to find the head of 10 features, which is the most important, can affect the price for the Airbnb. Then I use the PyQuiz to find which model is the best to describe this data set. And I got the result is LGBM because it has the lowest RMSE and the highest R square. So that's the best model I chose. And when the model is tuning, and after 5 foot, the R square is about 0.17. And finally, the R square can up to 0.27. This is the best model I found it in every model at here. So, and this is the prediction about actual price and predict the price. I try to make the learning curve getting more close, but when if I remove the if I remove the room type, the model will appear overfitting. So I add the room type back again. So and this is the pipeline. And after that, I choose the model is the LGB, the light gradient boosting machine. So and then I save this as a CSV, and my score is 8, 80, 20, 25, 225, and the rank is 77. Thank you so much.